All right, so that leaves the hyperbola. Or, if you will, hyperbola. We've already seen that hyperbola is because instead of a plus between the x squared and y squared, we have a minus. Same looking like an ellipse, except it's a minus between them. And then we also saw that we could have this happen. We have the y, and it's really all about which is first, the x squared first or the y squared first. If it's the x squared first with the minus between them, that is the right and left branches, okay? So we'll have this, the right branch, and we'll have a left branch. If we have the y squared first, then you have an upper and lower branch, hyperbola. Like this. Okay? That's what it amounts to for hyperbolas. Now we also have on the hyperbolas two focus points, two foci. Both of these, same thing. Either one, here's what the foci are. The foci are the distance from the center to, which of course these are centered up at 0, 0. And it's, again, c is going to be the distance. And it turns out c squared on the hyperbola is equal to not a squared minus b squared, it's a squared plus b squared. So on the equation it's minus, but on the foci you got plus. So it's switched around from the ellipse. Okay? For either one of these. Now, turns out the foci on this one are going to be here and here. That's going to be focus 1, that's going to be focus 2, here and here, focus 1, focus 2. So it's, again, kind of like the parabola. It's on the inside of the branches. The focus is always on the inside of the branches. Okay? All right. So that's the general rules about the, spelled that way wrong. That's the generalized stuff about hyperbolas. Okay? Let's do it. All right, so let's say we've got x squared over 9 minus y squared over 16. And it doesn't, in this, on the hyperbolas, it doesn't matter a squared and b squared, which one's bigger. It doesn't matter because you're adding them when you do the foci, so it's not that big a deal. What really matters on the hyperbola is which one's first. We've got the a squared first, so that tells me which type of branches. Left and right. Okay? Now here's what I do. I started out graphing it very much like I graphed the ellipse. I'm going to go out the square root of 9 is 3. I'm going to go out in the x direction 3. And this, of course, is centered at 0, 0. We'll talk about shifting them next time. There is no shift on this one, so it's centered up at 0, 0. So again, just like on the ellipse, I go out in the x direction 3, backwards and forwards. And then y, square root of 16 is 4. So we'll go out 4 in it. However, we know it's not an ellipse, so I'm not going to connect those elliptically. Now what I'm going to do is I'm going to connect those rectangularly. I'm going to draw a rectangle. I haven't told you about that, but there's what's called a fundamental rectangle, and if you draw a vertical line through that, and then a horizontal line to connect those together. That was too far out. Make it look a little better. Yeah, draw a rectangle like that. The reason I do that is because I mentioned the asymptotes. The asymptotes you can draw those diagonal asymptotes? Well, it turns out they're the diagonals, extended diagonals of this fundamental rectangle. So draw a diagonal extended through that, diagonal extended through the corners like that. And those are my asymptotes for my hyperbola. So you draw the box, the rectangle, and then draw the asymptotes by the diagonals. And so that's what my graph is going to be drawn to when I draw these in. Now, that's why this is very important, because I want to draw this, since we got the x squared first, I want to draw it with right and left branches. Well, if it's got right and left branches, then I've got branch over here, branch over here. Asymptotes there, and then I've got a branch here. This is a vertex over here, so a branch here, and a branch over here. That should be more curved. That's how you draw hyperbolas. That's the way it works. Right and left branch. Okay? So like I said, these these points in here are the vertices, kind of the turning points on these. So it's these, it's this point, what was it, -3, that's +3, so it's plus or minus 3, 0 are the vertices. These 2 points just help me make the rectangle, so they don't really come in on the graph here. All right, what about the foci? Well, the foci, the formula for hyperbola is what? What was it? A squared plus b squared. It's the opposite of that. Sign in the equation, a squared plus b squared. Well, a squared here is 9, b squared is 16. It doesn't matter which one's bigger on the hyperbolas. You can flip them around if you want to, but you'll still get 25, right? C squared is 25, so that would make c the square root of 25. Hey, that's 5. And so again, you want the foci inside of, I say inside, I guess it depends on your perspective there, but where do those go? Well, you're going to go out 5 from the center, and it's going to be along this axis here. So there's one focus, and then 5, 1, 2, 3, 4, 5 backwards, so it puts it at -5 there. Those are my foci, plus or minus 5, 0. Okay? One more. Questions or concern? Everybody got that one? All right. Do one more of these. Y squared over 49 minus x squared over 25 equals 1. Definitely in the hyperbola format. And it's not shifted. So centered at 0, 0. However, because the y squared is first, what does that tell me? The branches are up and down, right? Upper, lower branches. Okay, so I put that all here together. Now, be aware here, the y squared is first. So I'm going to go out square root of 49, 7, which way? That one's not in the x direction because it's under the y. So I'll go out 7 in the y, 7 up, 7 down, in the y direction. Because it's under the y. And that's why we go out in the y there. And then in the x, I go out the square root of 25, which is 5. -5, positive. And since it's a hyperbola, what do I do with those points? Draw the rectangle. So draw a rectangle with those points on the rectangle. And really the only reason for drawing those points is to draw the asymptotes. The asymptotes are the diagonals. Boy, try that again. Bad angle. Trying to go through the corners there. There we go. Okay? All right, but where do I put, in this case, hyperbola? Because I can either go here and here, or I can go here and here. Well, that's why we noted here this one has upper and lower branches. And so, in this case, here are my branches, upper and lower. So I've got an upper one, it's going to be that. So I've got an asymptote action here. It gets closer and closer to that line there. So go out, and this is a vertex right there. And then I've got a lower branch with the vertex right there. So this one's going to get like that, like that. I draw one. All right? Which, you know, is not exactly easy, but it's a lot easier than doing point by point by point. You get a lot better graph, I think. Okay? All right, so, yeah, they'll want the vertices. Vertices here. What are these? This point and this point. That's 7 in the y, so it's 0, 7. And negative 7, so that would be plus or minus 0 plus or minus 7 would be the best way to write that. What about the foci? Well, c squared for hyperbola is a squared plus b squared for the c distance, c squared. A squared plus b squared, you can reverse them if you want, but it's c squared equals 49 plus 25. You're adding them, so it doesn't really matter which order they are in. 49 plus 25? 74. And so c is the square root of 74, which is about square root of 74. We got it? 8.6. 8.6. And again, I want to go inside or trap them here. So I'm going to go 8.6. There's 7, 8. So 8.6 there. So there's a focus right there. 8.6 down. So that'd be right about there. So it'd be 0 plus or minus 8.6. Let's just call it plus or minus 74. Square root of 74. With me on that? Is that okay? All right, let me just mention this this one here. Get it started for me anyway. What if I had x squared minus 16y squared equals 64? What do you think that one is? It's hyperbola, isn't it? However, it's not in appropriate hyperbola form as we would like it. What do you think I need to do here? Well, I need this side to be 1, so I divide by 64. Yeah, divide everything by 64. That'll be x squared over 64, no change there. That would be, what, 4? Reduces to be y squared over 4. That equals 1. That's the hyperbola form we would like. And so, yeah, we can graph it accordingly from there. Draw the rectangle, asymptotes, so forth. Right and left branches. Okay?